The Klystron Power Supply, signal generator associated with it are used to control the Klystron oscillator which is fitted to the waveguide bench. In this video, we are going to show you a step-by-step procedure by which it should be switched on, and after that how to ensure a good microwave signal has been established in the waveguide bench, and finally we are going to show you how to switch it off in a systematic fashion. As undergraduate students who are getting into waveguide studies, an exposure to this is highly required. Students, in this video we are going to show you how to switch on the Klystron. There are three units: the Klystron oscillator on the waveguide, the Klystron power supply unit, and a signal generator associated with it. So all these three units combined together, they form the Klystron power supply unit. There are two power supplies, the beam voltage and the repeller voltage. We are going to use these two voltages, and as a student you should know is how to work with these voltages to get the good supply. So let us just start. Step 1, switch on the power supply. Step 2, switch on the signal generator. And let us now go back to Klystron power supply unit. There is a HT button. Please switch it on. Right. Now, in the signal generator, set up a square wave of 1 kilohertz. How are we creating the microwave? The Klystron creates the microwave, but how are we going to use it? The square wave modulated microwave signal is what we are going to use. This was explained in the previous video as to how the microwave source works. So you should be in a position to understand why we are using that signal generator. So, and why we kept it at square wave 1 kilohertz. Now, coming to the Klystron power supply unit. There is a knob called meter select. There are three choices: V, C and REP. V and C represents the voltage and current of the beam. By adjusting the beam knob, you can change the beam voltage. So let us just put the meter select into V. So, and now the beam voltage reading is 236. We can change the beam knob and see that the beam voltage changes. Yes, so the beam voltage changes. Usually the beam voltage is not changed and it is kept at a particular level for your convenience. We will always work with the repeller voltage. Next, let us go to the beam current. We put the display select onto C and we see that the beam current is 21 milliamps. These are standards given by the company that has created this power supply. Now let us put the meter select onto repeller. Look at the reading. The reading shows 327. If you change the repeller voltage knob, as you change it, you see that the value goes from 326 down to 312, 300. So there is a scope for the repeller voltage to go till 240, it is going to 28. I think it can go till 100 volts. Now, this is the range of the repeller voltage. So we will have the repeller voltage to the starting point, which was around 330. Right. Now let us just slowly turn to the last part of the bench, that is called the detector, and as you see from the detector a probe goes to the DSO, and in the DSO now and the DSO has been switched on. Now I would like the students to observe carefully as the beam voltage is changed, as the repeller voltage is changed, Look at what happens to the square wave on the DSO. The beam voltage is being changed from 307, 6, 5, 304, 301, and please, as we change it and as it is still reduced, as you go along 270, 265, 258, you get a next square wave. Still, if we reduce the repeller, the square wave is down, and still if we reduce the repeller, again a square wave comes. Now still as we keep on reducing the repeller, the square wave goes down. Still as we keep on decreasing the repeller, another square wave comes, it goes down. Still as we keep on going, the square wave comes and it is going down. So the net impact that I would like to tell is, as we change the repeller, you see a square wave appearing and disappearing. What is this? As you changed the repeller from 326 and we have reached till 120, you saw that the square wave was formed, it peaked and it died down. Then for another small range of repeller voltage, there was no square wave. Then again a square wave was formed, it peaked and it went down. This kept on happening. Let us look at it again. Now the beam voltage is at minus 339 and you see a proper square wave on the DSO. Now let us slowly change the repeller. Let us just slowly decrease it. As we go to 327, see the change in the DSO. Let us just slowly decrease it. As you keep on decreasing it, see how the square wave reduces in amplitude. As we go down, now the square wave has gone. So from 330 till 310, you had a square wave formed, peaked and down. Now let us try to go still further down. 305, 4, 1, 298, 293. Let us wait. 284, 279. Yeah. So now you see around this voltage. Let us just slightly increase it so that we will see the birth of the square wave. Around 261 volt, you see that the square wave has come. Now if you slowly decrease it, see the increase in amplitude of the square wave. We have reached 249, and now if you further decrease, you just see the square wave expanding, and now you see the square wave is slowly coming down again. Let us just decrease it further, and now the wave is gone. So from 260 to 228, you had another square wave formed, maximum, and then going down. Let us just see once again. As we still decrease the voltage, you see that another square wave has formed and it is peaking, and then as you just still decrease it, the wave is coming down. Now look at the meter reading, it is at 200. Let us just stop here. Let us conclude like this: repeller voltage ranges and square wave observed in DSO. As we went from 330s to 305, the square wave was present. As we went from 304 to 265, there was no wave. And again around from 263 to 228, you had the square wave. What do we infer from this? We infer that when the square wave was seen in the DSO, there was microwave power propagating in the bench. So when the repeller was in this range, you had microwave power propagating through the bench. When it was from minus 263 to minus 228, you had the microwave power. When the repeller was in this range, minus 304 to minus 265, there was no wave. Now let us go back to the bench. I had said that at 336 to 305, there was a square wave. I made a statement. Let us see if it was true. You saw the microwave in a DSO. Now let us just see how it looks in numbers. We have a power meter. Let us take the detector output and connect it to the power meter. The power meter's function was explained in the previous videos. I request the students to go and revise it once again. Now, if you select the gain knob correctly, let us see what is the reading there. It reads minus 21 dB. This means it gives us a power level at minus 21 dB. Now, let us change the repeller voltage. As you change the repeller voltage, I request the students to see the deflections in the power meter. To get the correct deflections, the range select knob has to be adjusted correctly. For the convenience, it has been kept at 20. You see the deflections in the power meter. So, you should remember that from 336 to 305, we had the first microwave range. So, getting the beam voltage back to 306, yes. So, as you keep changing the repeller voltage, you see the change in the power levels detected. As you reach 306, the reading has come to its minimum. Now, till now we have seen how to switch on the klystron and get a good microwave in the bench. Now I am going to explain the process and show you how to switch off the system. In the other labs, when they asked you to switch off the system, you could switch it off directly and leave. This is not the case in our lab. Here, as we had explained earlier, the process of electron bunching happens in klystron. This electron bunching process has to be stabilized and it has to be reduced, and only then we have to switch off the system. To do that, there is a systematic process by which we do it. So, coming back to the Klystron power supply, put the meter select onto the repeller. To adjust the repeller knob such that we go back to the maximum repeller voltage, that was around 336. Yeah, it was around 348. Good. At this point, switch off the HT and wait for the entire repeller voltage to go to 0. Now, when it has reached 0, you can switch off the main supply and switch off the power meters, DSOs and the signal generator.